Welcome back, my friend. Today in this video we will be talking about solving quadratic equation by factorizing. This expression x to the power 2 plus b times x plus c is a trinomial because it has three terms: number 1, number 2, and number 3. And as I just mentioned, if there is no number in front of the variable, that means the coefficient is 1. So here the coefficient for x to the power 2 is 1, the coefficient for x is b, and the constant is c. So here we can use factorizing to turn this expression into terms like the product of two terms or binomial. Let me show you how. Okay, now my expression x to the power 2 plus b times x plus c, I can change it into two parentheses which are multiplied by one another, or each parenthesis is a binomial because it is two terms, as you can see. And then this one can also be simplified as x to the power 2 m plus n times x plus mn. So you can always use these two formulas to break any expression into multiplication or product of two terms. Okay, so let's do an example here. As you can see, x to the power 2 plus 8 times x plus 15. The coefficient of x to the power 2 is 1, as like the template here. The coefficient of x to the power 1 it's 8, and the constant it's 15. So if I want to follow this rule, I can break this expression into two product of two binomials. So let's try solve it together. Okay, so I want two numbers which if I add them together I would get 8, and the same two numbers, if they are multiplied, they would give me 15. Okay, so x, and I would say the two numbers could be 3 and 5. And this, you can always like finding the numbers would be much easier if you do more practice, because there are not many different combinations. It's really easy. You just need to do more practice. The only thing here which is very important, if you want to follow this rule, the coefficient of x to the power 2, it's always 1. If it's a different number, then there would be another formula to follow. But here, if the coefficient of x to the power 2 is 1, the expression, you can change it into products of two parentheses or two binomial, and then also this is the formula if you expand it. So that's a good example. X to the power 2 plus 8x plus 15, you can change it into products of two binomial, 3 and 5. Add them together, you get 8. The same two numbers, if you multiply them, you get 15. Okay, let's do another example. This example, x to the power 2 minus 12x minus 28. Okay, so I can make it into products of two binomials, but here I need two numbers which if they're added they make negative 12, and if they are multiplied they would make 28. Let's see, let's try to work it out together. Okay, so if the two numbers, so let's say if I want to get 28, one combination would be 4 and 7, but that doesn't work because they cannot add up to 12. Okay, the other combination would be 2 and 14, and then because it's negative 28, so one of these numbers should be negative. I put the negative sign for the bigger number, because when these two numbers are added together, the sum or the product should be a negative number. So 2 and negative 14, when they are added, it would be negative 12, and when they are multiplied, it would be negative 28. And that's the answer, so I just substituted here. Okay, let's do another example. Here, the two numbers added together are 12, multiplied together 36. What are the two numbers which, if we multiply them, we get 36? Let's say 9 and 4, which is not a good choice, because if we add them together, it wouldn't be 12. It would be 13, or if because it's plus, so both of them should be either positive or both of them should be either negative. So that's not the choice. For 36, another option would be 6 and 6, which I think it's a good choice, because if we add them together, we get 12, and if we multiply them, we get 36. So the first parenthesis would be x plus 6. The other one also would be x plus 6. So the two parentheses are identical, x plus 6 times or multiplied by another x plus 6. So I can simplify it further and write it like x plus 6, and because we have two of these, it would be to the power 2. Okay, so now let's talk about the special factorizing patterns. There are a few important patterns in math which you can just use them to simplify, or to use it in your algebra to make it easier for yourself to simplify big expressions into smaller ones, or even when you're doing equations of higher orders, you can follow these rules. So the first one, which is very important, it's a squared minus b squared, which is called the difference of two squares, okay? Because both of these numbers are raised to the power 2. So a to the power 2 minus b to the power 2, and it would be equal to two binomial, product of two binomial. The first one would be a plus b, the second one could be a minus b. And please pay attention that a and b could be a combination of variables and numbers or constants. So a could be x to the power 2 and b could be, let's say, 4. That's one of the most common forms of the factorizing pattern in math. The other one would be perfect square trinomial. As you can see, it would be a to the power 2 plus 2ab plus b2, b to the power 2, and then you can change it into a plus b to the power 2. Okay, if you remember the last example we did on solving quadratic equation by factorizing, let me show it to you. The very last one, x to the power 2 plus 12x plus 36. Remember, we were looking for two numbers which we add them, we get 12, and if we multiply them, we get 36, and we ended up with 2, 6, right? So as you could see from here, the two numbers, it turned out to be x plus 6 to the power 2, which is exactly a perfect example of perfect square trinomial. The second one would be, the second one would be a perfect square trinomial, but the difference with the number 2 would be here, okay, the middle term, it's positive. Here the middle term is negative, so the only difference would be the sign here. Here would be positive, here would be negative. Other than that, it's very similar. As I just mentioned, you could use them in many different scenarios, from equations, simplifications, divisions. Let's do a few examples to see how it works out. Okay, let's start with example 1. We have this expression. It has three terms, x to the power 2 plus 3 times x minus 8 equal to 0. Please pay attention that the coefficient of x to the power 2, it's 1. It's a trinomial, and as you can remember, we could break it into products of two binomials. But how? We need two numbers which they are added together, we get 3 plus 3, and if we multiply them together we get negative 18. So you can try to find different combinations, but as I mentioned before, it only comes with practice. The two numbers would be plus 6 and negative 3, because if you add them together, plus 6 and negative 3, the answer would be 3, and if you multiply them together, the answer would be negative 18. So this is how you can factorize it, and remember, two parentheses are multiplied together and it's equal to 0. So from here there is a very important rule in math which says if any number of different parentheses are multiplied by another and the final answer is 0, that means any of those could be a potential answer. That means any of these parentheses could be equal to 0. So here either x plus 6 is 0 or x minus 3 is a 0. So from here we get one answer, from here we get another answer. This is a very simple one-step linear equation. This is another linear equation. We solve these two and we get two answers. Okay, then we solve these two and we find the answer. One of the answer is negative 6, the other answer is plus 3. And this is what we expected because we have a quadratic equation, and for a quadratic equation the highest degree is it's 2, so we expect two answers. As you can remember, in one of my videos I talked about solving quadratic equation by the formula, and actually that is one of the best methods and easiest method to find the answer. You just have to identify A, B, C and substitute it in your formula. I want to solve this same example with the quadratic formula and show you that you will get exactly the same answers. So here, let's identify A, B, C. A is 1, B is 3, C it's negative 18. Okay, now I identified the A, B, C. I just put them in my formula. I just write down the formula to just remind you of. This is the quadratic formula, and A, B, C needs to be simply substituted. So x, 1, and 2, that means we are expecting two roots, 2 times A, and then here negative B plus and minus b squared, which is 9, minus 4 times a, and c, it's negative 18. So let's simplify it further. X1 and 2 equals 2. The denominator would be 2. That would be negative 3. Under the radical is negative 4 times negative 18. It's 72 plus 9. It's 81. And the square root of 89 is 9. Okay, so let's simplify it further. I would have two answers. Negative 3 plus 9 divided by 2, which is 6 divided by 2 is 3. The other one is negative 3, negative 9 divided by 2, which is negative 12 divided by 2, it's negative 6. So one of the answer is 3, the other one it's negative 6, and it's exactly as the factorizing method, the answer you got in the factorizing method. So I just want to make a point here that no matter what actually method you use to solve a quadratic equation, you should come to the same answer or to the same roots. So it's always like if you use the factorization method and you're not sure about your answers, you can either substitute them back in your original equation and make sure it's equal to 0, or you can use the quadratic formula and double check your answers. Now let's do another example. This is a little bit more advanced. because here you have three terms on one side of the equal sign, and on the other side you have another two term. So first thing you need to do, you have to simplify and rearrange and bring everything to one side and equate it to 0. So you can either use the factorizing method or the quadratic formula. So let's do it together. In order to bring everything to one side, I have to add negative 3t to this side and plus 5. Okay, so as I just mentioned, we add negative 3t plus 5 to both sides, and then I end up with this expression. Okay, I simplify it, and this is the final answer. But if you take a look at a little bit more closely, you would see that you can factorize, or you can factorize 2, or you can just simply say I can divide both sides by 2. So if I divide this side by 2 and this side by 2, 0 divided by 2 would be 0. But on this side, let's see what we get. Okay, so I factorize a 2, and from this side it turns out to 2 times this trinomial, because there are 3 terms equal to 0. Okay, so then what I'll do, I'll divide both sides by 2, and 2 divided by 2, they just cancel out. 0 divided by 2 would be 0. So that means this part, t squared, t to the power 2 minus 10t plus 25 would be equal to 0. So it turned out to t to the power 2 minus 10t plus 25 equal to 0. Now you have to see which factorizing pattern is this. If you remember, we had 3 very famous patterns. And this one, the third one, if you look closely, very similar to this specific question. So I just use the turn pattern, and I make it into 2 parentheses. From here, I find the answer, t equals 5 and t equals 5. That means this root is repeated twice, or there are 2 identical roots. Okay, so now let's talk about the zero product property. I mentioned about this a few minutes ago in this video, but I'm gonna emphasize it again and reiterate. So let's say if a and b are real numbers, or any algebraic expressions, and then a multiplied by b is equal to 0, then we can conclude that either a is 0 or b is 0. Okay, so let's do a few questions to make you guys understand better. So here, let's do this example. We had this expression. Okay, so we had to simplify and rearrange it. In order to rearrange it, we added minus 3t plus 5 to both sides. Then it changed to this thing, and then remember it equals to t plus 5, the whole thing raised to the power 2, which is also required to the multiplication of 2 binomial products. So from here you could say that either the first bracket or the second bracket is 0. So in that case, both of them, the answer would be 5. So again, that means t equals 5 is an answer, but it's repeated twice. So this solution this expression has got one set of identical roots. Let's do one more example. So let's say here we want to find the zeros of this expression. The expression is y equals an algebraic equation, quadratic, because the highest power is 2. The coefficient of x2 is 1. This one, the coefficient is -1, and here the coefficient or the constant, it's -6. If we want to find a 0, that means y is equated to 0, right? We want to find the values of x which makes this expression equal to 0. So here we equate it to 0, and then we have a quadratic function equals to 0. It turns into quadratic equation. You can either use the quadratic formula or use factorization to factorize it into 2 brackets. That's what I did. Remember, we are looking for 2 numbers which we add them together, we get -1, and if we multiply them we get -6, and these 2 numbers happen to be +2 and -3. So here I have 2 binomial brackets multiplied to one another equal to 0. So that means either this one is 0 or this one is 0. Therefore, x can either be -2 or it could be 3. So this expression would have 2 roots if it's equal to 0. And this is exactly what we expected, because for a quadratic, we usually expect 2 roots. Okay, let's start with another very nice example. Maybe you can pause the video and try to solve it on your own and then check back your answer. So, the first method I used here was factorization. As you can remember, this one is difference of squares. As you can remember from my previous notes, can you remember the first one, a special factorizing pattern? So a squared minus b squared will turn into 2 brackets multiplied to one another. Okay? And this is exactly what happened here. I have 2 brackets multiplied by one another equal to 0. So either this one is equal to 0 or this one. From here, if I equate it to 0, the answer would be 2. From here, the answer would be -2. So you can see I have a quadratic equation and I'm getting 2 different answers. Let's try solving it with another method, which is also called the quadratic formula. I again emphasize that quadratic formula is one of the best methods, and you can always, no matter what method you use to find the roots, you can always check your answer or double check your answer with the quadratic formula. So here, first of all, we have to define what is a, b, c. So from here, a is 1, the b, which is the coefficient of x, is missing, so it's 0, and the constant here is -2. And then I write the formula here again for you. So this is the quadratic formula. You just substitute everything here. The b is 0. So under the radical would be -4 times -4, which is 16. Radical 16 is 4. And here I have plus and minus in front, so you would have 2 answers, plus and minus 4 divided by 2. And as you can see, even from the quadratic formula, you would get the same answer as factorization. So again, here I emphasize, no matter what method you use, your answers should be the same. Yeah. There is another example. This is a very nice example. You can start working on it yourself. This is a quadratic function equal to 0, so it turns out into a quadratic equation. Please find the zeros, or in other words, solve the quadratic equation. Please pause the video, try to solve it on your own, and then check your answers. Okay. So the method I use here is quadratic formula. But before I proceed, I want you to pay attention to something here. As you can see, the expression is not arranged. It's not arranged in the standard format. So it started with a constant, then the x to the power 2, and then the x. So first, from here, you have to pay attention. when you're identifying the A, B, C to substitute it in the formula. So the first thing would be identifying A, B, C. So remember, the A is always the coefficient of x to the power 2, which is -1. B is always the coefficient of x, which is 3. And C is always the constant, which is 6. Then we have the formula. Okay, this is the quadratic formula. And then you substitute it. You substitute, and then it happens that under the radical is not, whole number, which doesn't matter. It doesn't need to be an easy whole number. It could be something like even radical 35. And then remember, you would have two answers. So one answer would be -3 plus radical 35 over -2. The other one would be -3 -35 over -2. And then if you want to find it in decimal format, you can put it in the calculator and find the two answers. Okay, let's do another example. This is also very interesting. Please again pause the video, try to solve it on your own, and then check your answers. For this one, you can either use factorization or quadratic formula. So I always start by factorization. Remember, this is one of the three common forms of the factorization patterns. It's the difference of squares. So it changed into two binomial algebraic expressions or brackets. And then remember, A times B equals 0. So that means either A is 0 or B is 0. In that case, if the first bracket is equal to 0, the answer would turn out to be 1 over 2 after simplification. And if the second bracket is 0, the answer happens to be -1 over 2 after simplification. So here you solved a quadratic equation by using factorization, and you found two answers. You found two different roots. One of them is plus 0.5 and the other is -0.5. This is method 1. Let's try using it from another method, which is quadratic formula. Okay. First, you have to identify A, B, C if you want to use the quadratic formula. A is always the coefficient of x to the power 2, which is 16. There is no x, so the coefficient is 0, and the constant is 4. Okay, so again, I substitute everything in the formula. Okay, and then I get two answers. And the two answers are exactly the same as the factorization method after simplification. So again, I have to reiterate that no matter what method you use, your answer should be basically the same.